Okay, so we're going to talk a little bit about null reference exceptions, which is, again, sort of the most prevalent problem that you could possibly have in C#. So what I've done is I've set up exactly the scenario that we were talking about in the Canvas page. So what I've got is an employee class. The employee class has a name of a person. It also has their department and their code. And I also have a name class that stores the metadata for the names, the first name, the last name, and the display name. Notice that the display name only has a getter, it doesn't have a setter, and the reason is the display name is really for display purposes. So what it's doing is it's formatting the last and the first name, just making sure that you can always get kind of a reliable formatted name. Inside of the name, we have a list of addresses. So this kind of seems maybe backward from what you might expect. You might expect the addresses to live on the employee. The sort of current standard way of doing this is to have addresses associated with a name. And the reason is because employees can sort of come and go, but you can also use names in various subsystems. So a name could also be associated with a contact or whatever, and you can very easily pick up that name and you can use it on something that isn't necessarily an employee. So usually these days you see addresses associated with the name. So in the address class we have the first and second line of the address, we have the city, the state, and the zip code, and then again we have the display. And so this basically just gives you what you would see on a letter or an envelope if you wanted to mail them something. So what we're going to try to do is we're going to try to illustrate two things. One of them is kind of unrelated to what we're talking about right now, and that is coding. So here we have an employee code. What we're going to talk about maybe week 5 and going forward in the semester is CRUD operations for large kind of enterprise scale systems. And so in order to do these kind of CRUD operations kind of appropriately or in an easy way, what you always want to do is you want to make sure that you have some kind of primary key or some kind of unique identifier so that you can actually go and find the employee that you're looking for, or you can delete the employee using only that code, and you don't necessarily have to use string matching, which we used in the first code along. And so we're actually going to cover this again in the code along that's coming. And we're going to talk about this a lot in the class. Ultimately, we're going to deal with this in a database setting, but now I just kind of want you to see it in general. The way that you implement it with only code is using a static field. So right here, what I have is a static integer, and what I'm doing is I'm appending that integer using string interpolation to an EM, which tells you that this is actually the code for an employee. You could have the same thing for a client or for whatever, and I am incrementing it each time I create a new employee with the constructor. So what this is doing is basically just counting up. So I create the first employee, it will be EM-1, the second will be -2, third, fourth, fifth, and sixth will follow in kind. Obviously the downside of this is that once you are done with the program, it won't actually save anywhere because this is just in memory, but this kind of gives you an idea of how identification and coding works. The second thing we're going to talk about is how these lines of code right here are going to cause a huge problem and how we're going to fix them with both null propagation and null coalescence, which is kind of the purpose of the video. So first of all, we're going to run this. I'm going to show you that it works as intended. And so here what we're doing is we're creating 3 different employees. And you can see here I have employee code EM-1, EM-2, and EM-3. Everybody's happy. So the problem comes when I try to actually print their names. So the important thing to note here is that in the constructor for the employee class, I don't actually set the name, and the name is not just a string, the name is a name class. And so we talked at the very beginning of last module about how class types are reference types, and the default value for a reference type is actually null reference. So what's going to happen is I've created an employee here. I have given it sort of inadvertently a null reference as a name, And so then when I reference display name on that null reference, it's going to blow up because this is going to be a reference to a null reference, which causes a null reference exception. So I'm going to run this up. And there it is. Object reference not set to instance of an object. This is the most prevalent thing that can cause a crash in production and testing and development C# code. This is the absolute bane of every .NET C# developer's life. It's very, very, very common situation, and it causes tons of production issues that nobody wants to deal with. So the question becomes, how can you deal with this? So there are three ways of dealing with it. The first two are kind of naive. So the first one would be you would have an if statement between these two lines that says if the name is not set, so if the name is null, come up with some display name or don't print it to begin with. Just print the code and be along with your life. That would certainly work. But as you can imagine, if you didn't write these classes, if you were actually using these classes and somebody that you didn't even know wrote them, you wouldn't necessarily want to have a conditional every time you wanted to reference a property on a reference type. That would be kind of ridiculous. And so indeed, in years ago, there would be dozens and dozens and dozens of conditionals trying to make sure that you weren't actually going to trigger a null reference exception without knowing that you were going to do it. The second way of doing it would be using a try-catch. So you could actually put this thing in a try-catch, you could catch the null reference exception, and then you could throw it away. So you could just suppress that exception and you could go on with your life, and that would be functionally equivalent to checking to see if you have a display name prior to printing it. Both of those scenarios require you to do quite a bit of checking before accessing, which is not an ideal situation, especially when you're dealing with very large systems that probably have many, many, many nested classes. And so here we have employees that have names and names that have addresses, but you could certainly have very large APIs that have references of references of references of references of references, so on and so forth. So you don't necessarily want to have to check each of those things every time. So what can we do? The first thing we can do is null propagation. So null propagation happens with a question mark before each of the dot references. And so what this is going to do is if I try to access first employee and first employee is null, instead of firing a null reference exception, it's going to take the null reference exception and pass it to the next reference. So here, if first employee is null, instead of blowing up, the dot name is itself going to return null. Then the second one is going to say, okay, well, if name is null, actually make display name return null. If I run this, what's going to happen is instead of getting an exception, I will actually get a null returned to string interpolation, and then string interpolation interprets a null string as an empty string. It's the same thing. And so now, instead of getting this nasty exception and then your client or your user is super mad, now they're just kind of confused because they don't have a name. What would typically happen is they would know that, oh man, I didn't set that guy's name. They would go to the name dialog, they would set the person's name, and then everybody's happy. So this has kind of saved the day. Instead of calling support and being super pissed off, your client now understands that they just need to go and fill the person's name. That is null propagation. And so we can make the same thing happen by propagating on all of these different references. And this one, and this one. Okay, so this is a much nicer scenario, but there are obviously going to be times when you don't necessarily want to just show a blank value. What you want to be is very explicit about what the user needs to do. So if you want to do that, you can use what's called null coalescence. So the coalesce operator is the double question mark, and what will happen is if it is passed a null, it will actually return a default value. And so you could put something like this in there. So if we start, Now, instead of getting just a blank, it actually has a imperative statement, set this person's name, and the reason is because the coalesce operator was passed a null, and it knows to replace that null with whatever's to the right of that value. Now notice, this was all strings because we're inside of string interpolation. These things still work with integers or with reference types or with whatever type you want. Basically, the two of them combined together allow you to do defaulting without if statements, without try catches, without any of that. And it's obviously very terse. So you can do all of this in one line of code, and you don't necessarily have to inject a whole bunch of code to deal with all these kind of errant cases. So again, the single question mark before the reference passes a null forward, so it propagates the null to the next reference. That's why it's called null propagation. And the double quote or the double question mark replaces a null with a value that's appropriate for the context, and that's called the coalescence operator. So the next thing we'll do is a code along where we kind of put everything in module 2 together, including this stuff, and hopefully that will kind of wrap things up. So thanks very much for tuning in. I will see you in the next video.